Hey everybody, what's good? What's going on? JB here, back. Another CyberInsight live stream. We're knocking out today's task on TryHackMe's Advent of Cyber. This one is dealing with memory forensics. It can seem like a really a daunting thing to cover, especially if you've never done it before. Seems super in-depth and overly technical, but don't worry, this is going to be pretty basic, easy to follow along with, and by the time you're done with this, which won't take too long, you'll have done your first analysis of data from a Windows box, and done a little bit of forensics on it to hopefully end up finding some information that can help the elves track down some malicious stuff on some workstations they have up the North Pole. So why not? If you have any questions, throw them in the chat. Make sure you smash the like button, subscribe to the channel, all that other good stuff. We're going to dive into this and see how it goes. So the story, the background going on here, the elves in Santa's Security Operations Center are hard at work checking their monitoring dashboards when Elf McDave, freaking Dave, man, one of the workshop employees knocks on the door. The elf says, I just clicked on something and now my workstation behaving all kinds of weird ways. Can you take a look? So Elf McSkitty tasks you, Elf McBlue, to investigate the workstation. Running down to the workshop floor, you see a command prompt running some code. Uh-oh. This is not good. You immediately create a memory dump of the workstation and place this dump onto your employee-issued USB stick, returning to the SOC for further analysis. So we plug in our USB into our workstation and begin the investigation. Cool. So we're going to talk a little bit about what memory forensics is, why it's useful, and a tool that's a free tool that runs on Python to be able to do this. So for those who don't know, memory forensics is analysis of volatile memory that's used in a computer when powered on. So a lot of times that's why they don't want folks to power off a computer when there's something going on here, because there's important forensics data that you can pull off of there that will help give incident responders and blue teamers a better chance of figuring out what actually is going on and what's happening. Computers use dedicated storage device called RAM, or random access memory, to remember what is being performed on a computer at a time. RAM is extremely quick and is the preferred method for storing and accessing data. However, it is limited compared to storage devices such as hard drives. So this type of data is volatile because it will be deleted whenever a computer is powered off. RAM stores data such as your clipboard and unsaved files. So we can analyze a computer's memory to see what applications or processes, what network connections are being made, and other types of useful information. We can use and analyze the memory of a computer infected with malware to see what the malware was doing at the time, what other processes it might be interacting with, what type of connections those processes are making out across the network. So let's think about cooking. You normally store all of your food in the fridge. A hard drive is the fridge. When you're cooking, you store all the ingredients on the kitchen counter so you can quickly access them. The kitchen counter RAM is much smaller than the fridge, i.e. the hard drive. So memory forensics is an extremely important element when investigating computers. So a memory dump is a full capture of what is happening in a computer at that particular time. For example, network connections, things that are running in the background. Most of the time, malicious code attempts to hide from the user. However, it can't hide from memory. We can use this capture of memory for analysis at a later date, especially as the memory on the computer will eventually be lost. So as we mentioned, powering on off, for example, we power off the computer to prevent malware from spreading. By analyzing memory, we can discover exactly what the malware was doing, who was contacting it, and such forth. There's also different types of software that we have from a security perspective that could be installed on computers that actually will kind of capture this background information, the what's going on in memory. And that way you don't need to necessarily run and try and do a memory dump. It will keep that for a certain period of time. I think you'll find that some EDRs might do something like that. So introduction to a process. At the simplest, a process is a running program. For example, a process is created when running an instance of Notepad. You can have multiple processes for an application. So every time you click open Notepad, it's going to start a new process. This is important to know because being able to determine what processes we're running on a computer tells us what applications we're running at the time of capture. You'll also end up seeing that these processes normally end up having some type of ID numbers with them, known as a PID or a process ID, and I think we're going to probably hit that up here a little bit later. On Windows, we can use Task Manager to view and manage processes running on your computer. You might be familiar with this. Sometimes if you have an old computer, slow computer, a lot of times people open up Task Manager and maybe try and quit a process that's hung. And it's just making your computer really, really slow. On a computer, processes are normally grouped into two different groups. User processes, so these are things that we as users interact with and open up. So that would be like web browsers, Zoom, Microsoft Teams, things like that, Notepad. And background processes, these are automatically launched by the operating system and kind of lend themselves to the functionality of making sure everything works behind the scenes. So the tool that we're going to be using today to take a look at the memory dump is a tool called Volatility. It's an open source memory forensics tool set, and it's written in Python. So Volatility allows us to analyze memory dumps taken from all sorts of different operating systems, Linux, Mac, Windows, and it's very, very popular in the memory forensic circles. So some things that Volatility allows us to do: we can list all processes that were running at the time of the capture. We can look at active and closed network connections to see what the device was talking to or listening for. You can use Yara rules to search for different types of indicators of malware within the memory. I'm actually surprised we haven't hit Yara yet in the Advent of Cyber. I'm sure we will. They had a really good Yara room last year, and they actually have some other ones that are much more in depth that you can go and check out if you're unfamiliar with what Yara is. Retrieved hash passwords, clipboard components, and other things, contents of the command prompt, stuff that could have been saved within RAM. So once Volatility and its requirements, i.e. Python, are installed, Volatility can be run using this Python 3 and the vol.py. So you're just calling pretty much the Python script to run. And if we want to see the help menu, then we can just do a -H after that, and it will kind of give us a breakdown of some things. So we're using Volatility 3, which is a newer release compared to Volatility 2. There's a few different arguments that we're going to kind of cover here. So we already talked about starting it up. Then we might be interested in pointing it towards where the memory dump is that we're going to load. So that would be like this F flag. If we want to increase the verbosity of the information, so if we want to get more information out of what it's showing, we can do the -V. If there's different types of plugins that we want to use, we can use this -P to point towards those other plugins. And then this -O allows us to specify where we want to extract particular files that come out of this analysis versus it just going to the default location, which I believe is wherever Volatility is loaded from a folder perspective. So finally, we need to decide what we're going to analyze for. So we have plugins to do different things, listing the processes. So we're talking about like the applications that are running at the time, looking at network connections, contents, and a few other things. If you're interested in a whole bunch of the other options, you can just go to this link here. So in this task, we're going to be trying to find out what operating system the memory dump is from, see what processes were running at the time of the capture, and see what connections were made at the time of the capture. So in order to do this, as I mentioned, the first step is determining what type of operating system the device was running. We do know that it was a Windows box because that is just what they use in the SOC up there for their normal stuff. So we're going to use this image info plugin to analyze the memory dump. And it's just going to be this Python 3 vol.py -F, remember, is for the particular dump that we're using, and then the plugin that we're going to use after that. So we're gonna do that, and we can let that run. The only thing we need for this room is this machine right here. Just hit the start machine. It'll take a couple minutes for that to spin up. I already have it up, so we actually can just go and let's see where this is. LS. So let's go into Volatility because I think that's where everything is. Okay, so we have within here Volatility. Here's the Python script that we need, and here's a workstation virtual memory that we've dumped. So Python 3 vol.py, and then it was -F workstation vmem And then it was the plugin that we were going to do, I think was windows.info. So we're just going to go windows.info. Okay. And we can let that run, and we can talk about a few other things while that's going, because that could take a little bit of time. We'll see. So once we've determined what it is, then there's specific plugins for that particular operating system. In this case, I think kind of know that it's going to end up coming up as Windows. We don't necessarily know what version of Windows, but we know it's going to come back as Windows. Here we go. Yep. So what do we see here? We see Windows and version 10. So Windows 10. Okay. So what are some things that we might want to look at within a Windows system? So we might want to discover what processes we're running on the system. We can do that with this PS list plugin. We might want to know what the specific processes we're doing. So this is this PS scan. Kind of goes a little bit further detail into the actual processes that were discovered. If we want to export a specific binary and allow us to do further analysis on it, whether it's static or dynamic analysis, this plugin allows us to export that out of the process. This is the dump files. And then if we wanted to list the network connections at the time of the capture, we can do this. So for example, they mentioned here was a process causing the computer to connect to a malicious server. We can then take this IP address that actually at that point might be used as an indicator of compromise, IOC, and to implement defensive measures on the device or within the environment. So these are kind of just the outputs from these. I think we're pretty much just going to run through these. We already ran this, so let's see what they want us to do. What was the version number of the memory image capture? So that was Windows 10. Now, what is the name of the binary gift that Secret Santa left? So we can look through here. We can do, maybe we'll do the windows.ps list. PS list. And we'll see how long this takes to go. Shouldn't be too long. Okay, and then this dumped out a whole bunch of stuff. So we can see all of these different processes here. What do we see up at the top? What are the outputs here? Image name, image file name, offset. So I mentioned the PID, process ID. Other thing, the threads. When it was created time, exit time. Okay, so what do we have in here that looks kind of interesting? These all kind of look like normal Windows processes, the service host, VM tools. I'm just looking for something that might stick out. Start menu, runtime broker, security health, SkyApp. Sometimes you also find that folks that are doing bad stuff will try to rename stuff very close to different processes and things like that. That would be common so that it doesn't necessarily stick out to somebody who's just using their eye to move through these things. Python. Well, here, all the way at the bottom, is mysterygift.exe. So that sounds like it might be something. Let's see if that's what it is. Gift.exe. Okay. What is the process ID of this binary? What is the PID? So we already see that there. So that looks like 2040. Okay. While we're in here, let's run some of these other things. So I think we just did Which scan did we do? PS list. Let's do a PS scan. And the other one that we might be interested in doing is a Windows netstat. That could be fun. So letting this finish up here. Okay. It kind of looks like it's giving the same information as what that other one was. I don't see anything that's really bumping out here. Again, we can see the name and the PID. Okay, I just hit Control C on that to cancel that. So let's do the Windows.netstat. See if anything interesting comes out of that. And while that's running, we can see what the next question is. Dump the contents of this binary, how many files were dumped. So to dump the binary, we got to use a dump files plugin, and we got to call the specific PID that we were looking at, and that was 2040. So we didn't really see anything. I don't know if maybe just within that file it was missing that, or maybe the way that they made this didn't really have any network traffic going. I'm not sure. I'm not sure why that's not coming up. So let's just do the dump files, and then it was the PID --PID 2040 --PID 2040. And we'll see what this comes up with. So based off of this, they just want to know how many files are dumped. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now from this, we could then go and do some static or dynamic analysis on these different things. Probably could take them and do maybe get some hash values, look that up, you know, kind of like we did before when we were going on virus total and things like that, and see if they match up with some other IOCs. But I think that was all they wanted here. So that was 16, I think. All right, so that was it. I mean, nothing too crazy. If this was your first time doing some forensic stuff, that's pretty cool. We're just using volatility, opening up the memory that we had, the output from the memory that we had saved. We're able to see kind of what processes were running, the PIDs for those. We were able to see the files associated with those PIDs, which then we could take and use for further analysis in some different places. So yeah, that's it. Pretty easy, pretty straightforward. If you have any questions, throw those in the chat, I guess. But if not, then yeah, appreciate you dropping in, and check you out tomorrow. All right, take care. Bye.